Hello again, everyone. This is Mr. Smith, and this is 6.7 Volume of Prisms and Cylinders. These notes are a little bit dated, so I am going to actually change it. Let me just change my pen color here. Here we go. Scratch this out. I only use one definition for volume, and that is volume is the capacity inside three-dimensional objects. So just capacity. So an example of this would be the amount of air in a balloon. Usually it's measured in space. The amount of paint in a paint can would be another example of volume. And volume is measured in cubic units. So cubic units. So like centimeters cubed, millimeters cubed, meters cubed, etc. That's generally how we measure volume. However, liquid is measured in milliliters or liters. Just a reminder that 1 milliliter is equal to 1 centimeter cubed. I'm not sure if we go too far into this. However, I'm going to star this and underline it just so that when you are looking at your notes, you'll know where to check for this if you ever get lost and wonder how to convert back and forth. There is real life examples of this, so it is useful converting from just volume to liquid measurement. And using metric is really nice because 1 cubic centimeter is equal to just 1 milliliter. So that's a nice conversion for us there. Okay, now that I've talked enough, the basic volume of a prism or a cylinder is just your area of the base times your height, h for height. And we've seen a lot of these symbols before. Capital A was the area, h, lowercase h was the height. So this isn't new stuff. So for the most part, that's all we're going to deal with today. Volume, just figure out the area of the base, multiply it by the height, and then you're done. With the volume of a prism is a three-dimensional object with two parallel polygonal bases. So polygonal could be a square, rectangle, triangle, pentagon, hexagon, octagon, decagon, connected by rectangles. So in the first example, we have a triangle. That is a type of polygon. It is a three-sided polygon. That's the tri. So triangle, and then it's connected through 3 rectangles on the front and the outsides, and then there's the base of a triangle. Again, excuse me. For a rectangular prism, we see it's a rectangle on top, connected by rectangles all around the outside. A cube is all square faces. And then a hexagonal prism, well, hexagon's at the top, hexagon's at the bottom. It's connected by all rectangles. So that's what a prism is. It has a bunch of rectangles that connect. Two faces are the exact same. So triangle, rectangle, you name it. So you guys have seen this before. I'm not going to go too much more in depth with that. The volume of this, though, you may not have seen. You might have seen this in grade 8, is length times width times height. My L is a cursive L, just so we don't get confused and it's a bit easier to see. Or in the case of a triangular base, so we're only dealing with rectangular bases and triangular bases right now. If you have a triangular base, it's your base of the triangle, height of the triangle, over 2, because that's the area of a triangle, right, in brackets there, and then times height of the polygon, or of the prism. So I'll go into more detail about that. We're just basically finding the area of the triangle and multiplying it by the height of the prism. All right, now the cylinder. A cylinder is a three-dimensional shape with identical circle bases. An example would be a can of soup. Any sort of can is a cylinder. I don't think that there's a rectangular can. Most cans are cylindrical. That means they're cylinders. And to calculate the volumes for these, well, to calculate the volume of a circle is just pi r squared, right? Well, it's just that times height. Or you could write it as pi r squared h. You can write either or. I like to use pi r squared in brackets just because that's the area of the base, then times the height. And that's how you calculate volume. Pretty straightforward stuff. Let's get into some examples now. First example here, calculate the volume of each of the following. We have it looks like a cube, but don't be deceived, it's not to scale. It is a rectangular base prism. So we have the width, the length, and then the height. And if we remember what our formula is, it's V equals area of the base times height. And because this is a rectangular base prism, it's going to be V equals L W H. So now we just sub in the L, the W, and the H. So L is 6, W is 4, and then the H is 5. You can plug this into your calculator, and you should get 120. And now for our units are centimeters cubed. That's what that little 3 is up top. Now, when you enter this in a Google form, I can't really make you guys do that. So if you just leave it as 120 or 120 centimeters, that's fine. Again, I will always double check Google form answers just because it's hard to program every possible right answer. Next example, we have a triangular base prism. Now, the triangles aren't on the base of it. However, we don't need to know that. Or we don't need it to be on the base. As long as we have two parallel sides, so we have the front side up here, and then the back side over here. So as long as those two are both parallel, they're the exact same shape, just in two different spots, that can count as the triangular base pyramid. So this is going to equal area of the base times height. So our volume is area of base times height. Remember, our area of the base is going to be base times height of the triangle over 2 times the height of the prism. Now, the problem with this is it's a little tricky because this is the height of the prism and this is the height of the triangle. So what I'm going to do is I'm going to label this as height of the triangle. So I'm going to put the triangle there just so I can differentiate between the two. And I'll put this as B as the base. You could have put height of the triangle where B is and B where height of the triangle is and reverse them. Either way, your math's going to work out because when you multiply and divide, you can move them around and the numbers work out nicely. So let's just plug all the stuff in now. I have 9 times 12 all over 2, and then multiply that by 18. Now what's nice about this is you could do 9 times 12 times 18 all divided by 2, or you could do 9 divided by 2 times 12 times 18. It doesn't really matter the order because it's all multiplication and division, and in BEDMAS, it doesn't really matter which one you do first. So in this case, particularly in multiplication and division. So in this case, 9 times 12 times 18, divide by 2, you should get 972 centimeters cubed. All right, next slide. Here we go again. We got another triangular-based pyramid, or triangular-based prism. Not a pyramid, this is a prism. But in this case, we're not actually given the height. This time, I'm going to label this B, label this H, and then I'm going to label this L up here. So my height of my pyramid is going to be L now. I'm going to use red to highlight this. Well, we need to figure out the height of this triangle, and in order to do that, well, first we need to determine what this length is down here in red. And it's exactly half of our base, so it should only be 5 here. Now that we know that, we can use a certain theorem, like the Pythagorean Theorem, to solve for our unknown. And in this case, we have L squared plus 5 squared equals 10 squared. So then L squared plus 25 equals 100. L squared equals 100 minus 25. Then we're going to square root both sides afterwards. L equals square root of 75. And we're going to round to one decimal place to keep things simple. 8.7 centimeters. Perfect. Okay, so now we know the height of this triangle. Now that we know the height of that triangle, we can actually calculate the volume. I am going to switch my pen back over to blue to calculate volume. I'm going to say my volume is equal to L, because that's the height of the triangle. I just used L times the base of the triangle all over 2, because that's the area of that triangle. This big triangle base, which I'm using blue to outline, and then multiply by the height of the prism. So now I can plug in all the numbers that I know. I have 8.7 times 10 all over 2. And then I could even multiply this by 20. Put that all over 2 there. So now I can multiply all these numbers and divide, and I should get 870 centimeters cubed. And I'm back. Okay, final example. Question or example D. We have a cylinder. What's nice about this is it's pretty straightforward for cylinders because I can't make it more complicated than it already is. It's just volume equals area of the base times height. And the area of the base is just pi r squared. And then we're going to multiply that by the height. So now I can sub in what I know. Well, pi is just itself 3.14159, or 3.14 is fine. And then my radius, which is 6, that's going to be squared. Multiply that by 12.5. So again, because I'm multiplying, I could multiply by pi first, last. Doesn't really matter which order I'm multiplying by. What I would do first is do the 6 squared. So I'd end up with pi 36 times 12.5. And you should end up with 1,413.7 centimeters cubed. And that's it for that. If you have any questions, make sure you ask. Do the practice, then do the quiz. Do both lessons for this week, and good luck.